Hi everyone, I am Nirlav Mukhtar and today I am going to talk about something that sounds little crazy. Have you ever wondered how does your nose actually work? But if I tell you that every time you smelling something, your nose might be doing quantum physics. Yes, quantum physics. Right inside your face. Here you have see three picture like smelling fragrance, smelling food, smelling flower. All this work we do in our regular life, but mainly we don't think about how this actually works. All right, first look at the classical theory, that one we all study in school. When a small molecule enter our nose, it meets lots of tiny receptor. Think of them as a lock. Each receptor has a special shape and only the right molecule, the key, fit into it. When what happened? Your brain gets a signal and say, "Oh, that's the smell of chocolate," or "That's pizza." Simple, right? But science rarely stay that simple. Here, where the theory start to smelling a bit fishy. Scientists found that some molecules with different shapes but smell the same, and other the same shape smell completely different. Take an example of carbons. It's the same chemical formula, but one version smell like mint and other smell like cumin. Even more interesting isotope which have the same shape but slightly different but same different too. So if shape is not the full story, then what is? And that's where thing gets quantum. In 1996, a scientist named Luca Turin proposed something revolutionary. He said, "May our nose don't just look at the shape of molecule. Maybe they actually listen to its vibration. You see, every molecule vibrate at a unique frequency like a tiny musical note. And according to the Turing, when an electron in your receptor tunnels through the molecule, it can detect the vibration using a process called quantum tunneling. So, in short, your nose might be a quantum detector, literally sensing molecule music. Next slide. This is the quantum view, which I explained in the previous slide. That our nose receptor detect vibration of the molecule, and they using quantum principle like quantum tunneling, and then detect which type of smell. Okay, if we want to compare classical and quantum theory, classical theory which based on shape and size of the molecule, and quantum theory which based on the frequency. Classical theory cannot explain isotope, but quantum theory explain isotopes. In quantum theory use quantum tunneling. uh, the classical theory, which I said in previous slide, which we all study about that, but the quantum theory but the quantum theory is now ongoing in research. So main thing is why it's matter. Now, why should we even care about all this? Because smelling is not just about perfume or food, it's about survival for detecting gas leak or to recognizing spoiling food or fire. Our sense of smell keep us safe. If quantum mechanics really help us smell, then means quantum physics is alive inside us, happening every second. And the applications are fascinating. We could design better perfume, flavor, or medical sensor to detect disease just by smell. Imagine diagnosing diabetes or cancer from someone's breath, all thanks to quantum biology. Of course, not every agree with this idea. Some scientists say no way, biology is not that quantum. Or others said the evidence is not right. So the debate continues. And that's the beauty of science. We keep questioning, keep exploring, because curiosity is what drives discovery. When I start researching this topic, I never thought something as simple as smelling could involve quantum physics, but now I feel like my nose is doing experiments every time I breathe. All that tell us something amazing. Quantum physics can appear anywhere in life. Maybe the next big discovery will not come from a fancy lab. It might be come from your body, your brain, or even your biryani. Okay. So thank you so much for listening this. Thank you. Good night. Okay.